Hi everyone. Oh, I'm looking at the wrong place. Hi everyone. My name is Shreya and welcome back to Tech Talks with Shreya the Cray. Our special guest for today is Stacy Cashmore. Hello, Stacy.
Hi, how are you doing? Thank you for having me here.
Yes, just wait, did I pronounce your name right? Is it
Yep, you
Stacy
pronounced it
Cashmore?
right. Yep,
Okay,
Stacy Cashmore.
fantastic.
I'm English, so I like to confuse people. It's my name's Stacy, but I go by Stace most of the time, so that's what's on the screen.
Okay, got it. We'll call you Stace then. I'm really grateful that you took the time out. I know you've been very busy in the last few weeks. You've had like events and talks and all sorts of things. So thank you for taking the time out today and having this conversation. It's definitely an interesting one for me. We were talking about it earlier, how for most people, like students at like the early engineering stage, you learn about serverless as something that you just like get started with, right? Like you learn how Azure works, you start working with functions, and you build your project directly on it. But we don't talk as much about what happens to those products and companies that were built maybe like 20, 30 years ago where serverless wasn't big, or at least it wasn't popular. And what did they just stay with servers, or did they end up having to do that transformation into serverless, integrating it into their product, and like what that experience is like? And that's something that you're quite familiar with, right?
Now, that's something that we're going through right now. The company that I work for, Omniplan, in the Netherlands, they started 25 years ago, and they actually started with an Excel workbook. That was their first application, was written in Excel.
Wow.
And they used that for a few years, and then they moved to a Silverlight application. So that was when Microsoft tried to take on Flash. And obviously, Silverlight needs IE to run. It only runs on Windows. Silverlight is out of support. IE is out of support, and they needed to change. And they had one attempt going to um, a service orientated system, but it was kind of a failed attempt. It turned a little bit into a um how does it call it? Sam Newman calls it a distributed ball of mud. It is different services that can run around the place, but they are all so interconnected that it failed often. Nobody really knew how it was going to get deployed. It was in one solution, 140 different projects. So it made machines really slow. And it didn't scale. It was hard to work with. It was lots of shared models, so everything was talking to everything else, and it just made life really hard. And in 2020, we actually had a conversation with management, and we had that conversation, which I've had so many times in my career. It would be quicker to throw this away and to start again. Terrible idea, don't do it most of the time. But management actually listened to us, and they gave us the chance, and we had to prove that we could actually do this. And so, yeah, we did throw everything away, but we're still stuck with the expertise that we had in-house. So we had a very, very tight deadline. We're 18 months into a project, and we're starting from scratch.
Right.
And we decided that whilst we wanted to do the really cool serverless things, and we could really see where using eventing and queues and functions could really benefit the application, we also knew that moving a company from the old way of programming into the serverless way of programming and getting everybody on board with messaging and learning as we went whilst developing software on a really tight deadline, that was just never going to work. So we made a deliberate choice to stay with Azure App Service Plans, to deploy web APIs, and know that we needed to build it on the inside in such a way that we can move it to functions at a later date, but not to have to learn them right now.
So let's get into that a little bit more. Is like, what was the process of making the decision in the first place? You mentioned that obviously the team had to make a decision. You had to convince management. Normally, management isn't going to listen, but in this case, they did. What were like the arguments that you were making that convinced them?
And the arguments that we made, I think it was we managed to do it with empirical data. I think that was the big one. I mean, I joined the company quite a long way into the process of the first one, and I spent 6 months watching the team struggle, and things which should have taken days or weeks were taking months. And on top of that, I think the first month that I worked there, our test environment was down that often because things were breaking other things. It was a really easy empirical discussion of, look, we know that you have all of this code and we know you've got all of this investment, but really, just look at how long it took to do one simple thing and then extrapolate that to the rest of the backlog that we have. It's going to be quicker to start from scratch, and these are our ideas on how we would do this. And I think that also helped when you can go in and say, this is too tied together, so we want to go for this structure instead. And give them not a plan with a timeline, because we still had way too many unknowns with the software, but at least with a plan of how we want to attack it and how we want to try and make sure that in the future we don't have to say we've got to throw all 140 projects away and start from scratch, but that we can modularize it in such a way that we really can replace one service without replacing the rest of the system.
And it's definitely like a drastic shift in your product. How, like, what research did you do? How did you decide that that was the right decision to make and that you weren't going to end up like screwing yourselves over in the future?
The way that we decided, again, it was just looking at the old one. The research me and the other architect knew. We had a discussion about this a few times. It's like, we could rebuild it in this way and it would be better. But looking at the existing application, there were just so many smells in there. So one of them was literally nobody knew how this was going to be deployed. We had a pipeline set up that deployed everything automatically into a test environment, but it wasn't production ready, and there was no plan on moving it from production ready further. And when we saw people making changes, because all of the models were shared between all 140 services, if you change something in one place, you'd end up having to change 20 or 30 different files just because of this one code change, even though they were unaffected. Nothing should break in them, and nothing should break in them, but stuff did break, and we didn't have the ability to test it in such a way that we could prove things were working either. So it was kind of the whole gamut was not where it should have been. It's we didn't have confidence in our deliveries. Testing involved getting somebody to manually click through a site. We couldn't automatically check things. The code wasn't suitable for automatic checking. So if we'd have wanted to add the unit tests into that code, we would have had to have rewritten the code before we added the unit tests. And it was just, you get that many things piling up that at some point you've got to say, this just isn't tenable.
Mm-hmm. What did your team look like at the time, and like structurally, how did you know that your team would be able to take on this change?
The team at the time, we had teams working on a couple of different things, and we had a lot of people with a huge amount of experience in the domain that we were working in. Financial planning has a lot of really complex relationships and calculations. We had a few people in that were external people helping us in the short term that could help the people who've been with the company for a while to get up to speed with different programming techniques, and really helping them think about how to develop quality software from the start and not have that wait for it to be tested mentality, but really help them move to the place where we can shift the testing left and get some automatic checking in place. On top of that, the architect that I work with is an amazingly intelligent person that we could really spar together well. So we could have arguments, but we could have really nice professional arguments. And we knew when to give for each other. If somebody came up with a better idea, it's kind of just being open for that and trying to get people into the new mindset. And it was a big shock. It was, I'm actually writing a talk at the moment about the mistakes that we made from moving, not so much the way that we developed the application, but the ideas we had behind it, in that we went to a full-on CI/CD pipeline. So we went from the wait for testers to test and we don't know how we're going to get it to production, to a this is going to production from day one, so you better be sure that it works. That was an interesting journey too. I say that's and just bringing all that together, we just really tried to make sure that we could support the team. We had enough external people with modern development techniques. We had enough internal people that wanted to learn. We had plenty of people with the amazing domain knowledge that was needed to move forward. And putting it all together, we managed to make something that worked. We formed 3 teams for the 3 main areas that we had, and we figured out a way of getting them to work, and I kind of floated between the teams as needed.
Gotcha. So we went from, we clearly have a problem, this is an ambitious way to solve it, but like we think we can do it, and for most part everyone seems to agree. Having some sort of like actual plan of action, knowing that you're working with a good team that can pull things off, or at least work together and try to pull things off. What was the process after that, like the actual migration process, the training process, like what's required to get from where you were to where you are today?
We went down the sink and swim route, or sink or swim route, I should say.
Yeah.
So we literally got down to one day and we made the decision, and within a week we were doing it. Mm-hmm. So we said to the teams what we're going to do. We got the seniors in and we had an architecture session so that we were all on the same page. So we could put our ideas out. A lot of things were accepted off the bat. Some of the senior developers had some different ideas, and we made some compromises because we've got to take them on this journey as well. You can't just ride roughshod over the senior developers. I've been a senior developer when our architect's done that, and it's not pleasant, and it doesn't promote a good way of working. And then the senior developers looked after their teams. I say sink or swim because we switched day to day. So one day we were using the old system, and the next day we got the developers, we had the discussions about what we were going to be doing, and we threw everything away. We said to the developers, the old code is there, it's in a different repo. We can look at it for functionality things. So you can see what functionality has already been implemented. We can check that we are not losing functionality, but you are not allowed to bring any code over. We are writing everything from scratch, which an amount of people disagreed with. It's like, we've been working 2 years on this. You can't throw all this code away. It's like, I'm sorry, we are, because bringing it over is going to make more work than retyping it. And with a new way of doing things, we moved to an onion architecture rather than the big ball of mud monolith. And that meant that we weren't sharing these data objects between everything. Every service and every layer in the service had its own object model that it works with. So you can't just bring stuff over from the old system because it's just not going to work. On top of that, we told them that we were doing the CI/CD, and that was an absolute baptism of fire. That was, okay, we're doing this, and as of today, we are doing this.
Right.
It led to some interesting discussions. It went wrong a few times, but of course it's going to go wrong a few times. It was an entirely new way of working. And we wanted it to go wrong at that time. We were replacing a system. The old system was in use, so we weren't strangling it. It did mean that we weren't live immediately, but we had an acceptation environment that was production-like and production-ready that we deployed into constantly. And we wanted that to break because we wanted people to learn from when it broke so that once we're in production, hopefully we don't have those troubles. We're still going to break it in production at some point, of course, but we didn't want to do it as often as you do it early on in the beginning.
Right. So, yeah. Sorry, you made a lot of really good points, and I want to kind of like go back to some of them and ask some more questions. The first point that you made was like how architects, it's really difficult when architects start to like do their own thing and don't run things by senior engineers. Could you tell me a little bit more about what the responsibilities of those two roles are and how they differ or how they should be working together?
Right, so the way that we have the architecture, officially I'm not an architect, but I work with the architect, and I did an amount of architecting in this system. But the way that we work together is we bounce off of each other and we come up with ideas. Certainly at the beginning we did this and came up with the ideas. We got the senior developers in and we gave some of our ideas. We said why we were doing the project in the way that we were doing the project. And then it's for the senior developers to tell us why we're wrong. So, yes, what do we have wrong? What have we missed? What are better ideas on top of what we've done? And make it a collaborative effort. The main thing from that point onwards that me and the architect can do is stop circular conversations. Because it's really easy. If you've got 5 developers, then you've probably got 6 or 7 different opinions. And you can end up just going round and round in circles having these discussions. And I've been in teams where there wasn't anybody that had the authority to step in and stop. And having 2 people with the ability to say, look, these are all awesome ideas. We're never going to pick the best one because they're just different. It's not that one's better than the other. And so we're going to go with this one. And it's sometimes you can just say, no, this is the one that we need to be going for right now. Other times you just have to go, look, they're both as good as each other, so we're taking this one. And you're going to make sure that you're not always favoring one person. But it's also a way to make sure that you are really getting the best out of your technical leads and the senior developers and getting all of the input that they can give. And yeah, I say not just being the way that we used to call it in one of my previous jobs was the architect in the ivory tower. They make their architecture and they throw it down to the developers and you have to do it. And we really didn't want that. We really wanted that collaborative effort and making sure that we all had that communication with each other.
Yes, definitely. And then I think the second point that you made was about how you chose to leave all of the code behind. And that's definitely something I'm sure had a lot of disagreements and a lot of arguing, and that you had to start from scratch, which I also understand. Like, it's like when you take code for like a college like homework project assignment, right? And you take code off of Stack Overflow and you try to throw it into your project and it's not going to work, but you're just kind of like, I hope it works.
Yes.
But obviously much higher stakes, right? You're building an actual product, not just an assignment in this case. What are some of the things that you learned in that process and that decision and the aftermath of that decision?
I think the main thing that we learned is that you can really temper your decision to put off difficult work. So for the most part, it was, nope, we can write this from scratch really quickly and we can prove we can write this from scratch really quickly. I think within a month we had the core of the application up and running in the new system. It was really quick compared to the old system. It was maintainable. We could change things. That kind of proved our ideas. But there were 2 parts that were still completely the old system. They were the core calculations for 2 different places, one for our mortgage software, one for the general financial calculations. And rewriting those is something we need to do a different day. They are hideously complex. They're complexly written. The calculations are complex. They need some real serious thought put into the rewrite. And we knew we weren't going to get that time. We weren't going to get the budget to get the people to rewrite that quickly. So there we knew that we had to do a lift and shift. We could move it into an app service plan, so that's fine. We weren't taking VMs into the new system, which was an absolute no-no. And the thing that we took from that is we can do this in a safe way if we think about what we're doing. So we took that old system, but we made sure that it had absolutely no impact in the new system. So we figured out what interface we wanted to work with in the future. We wrote that interface, and then we put the old system behind that interface. It meant another layer of adapters and wrappers and not necessarily fun code, but it means at least that the new system only talks the new language. And that's the problem that the old system had. It had 3 different versions of one particular model system, and it had to convert. I saw some of the graphs. It converted from A to B to C to 8.5, and then it has to go back the other way, and we didn't want that in the new system. That can stay in the old system. We know we've got to reuse that code, but we can bring that over. We can put that in its own app service plan with a new... I've got the Dutch expression in my head right now. A new jasje on heem, a new jacket, the Dutch call it.
Nice.
So that the rest of the world doesn't even know it's speaking to an old system, which is just going to allow us to replace it in the future when we have the time and energy that we need to go really in depth. We can do that and not worry about breaking things. And that was kind of the number one thought at that time. And I think that was an interesting one working in the project, because obviously when you say, look, we've got to rewrite everything in your head, you've got to rewrite everything. And then reality kind of hits, and it's like, okay, we can rewrite 95%, but this 5% is going to be 8% of the work, so it's not happening.
Yeah.
And figuring out the way to do that, but still make it future-proof. That was an interesting challenge, and I think we solved it in a good enough way.
Gotcha. And then in terms of what you're, like, where are you at currently in the process?
Well, this week actually, we went live yesterday with the application for our financial planning. We went live last year with our mortgage application. So we've now got to the point where we are taking stock of where we are. We've got the big main challenges out of the way. We now have no Silverlight. We now have no IE dependencies. People on Mac can use our application, which is awesome.
Yes.
So apparently I did hear from one of the business consultants that it's always so disappointing if you're demonstrating something and the end user goes, that would be fantastic, until it runs on a Mac. I can't use it. So now we don't have that problem anymore. We can run on Macs. But now we can stand back and take stock. We can look at a year and a half of a lot of stress, a lot of effort, and we've got to let people take a breather. And where they're taking the breather, we can really examine the shortcuts that we took because of the stress, because we're software developers. That's always going to happen. We were learning on the process as we went. And also look at how the app's functioning. So I said that we knew we needed to move to a messaging system, and we knew that by not doing that, we were going to have a little bit of a chatty application, because we have the different services and they need to talk to each other to get data instead of it being sent via messages asynchronously. It's a little bit more chatty than we'd hoped. So we already see the places where we really need to start working on this. And that's going to be the next step, figuring out how to move that forward. And a good place to get the teams involved so that they can learn the messaging systems. And to be honest, us as architects can learn good messaging systems, because it's a new one for us as well, in order to get everything communicating. So we're going to pick out some simpler flows, some of the easier ones, and we're just going to start with getting some cues in there to make the things that can be asynchronous, see what we learn from that, and then try and expand it one piece after the next.
Gotcha. So my next question is more related to like the actual serverless integration side of this. Could you tell me architecturally what that looked like, what aspects of serverless you're using, how, yeah, like what that integration process looked like?
Well, at the moment we have serverless storage. That's something that we took from the beginning. It's we didn't want to we didn't want to pay for SQL Server, and we also didn't see the need for SQL Server with the data that we had. So we went for Azure Table Storage, which is cheap. It's relatively simple to use. It is reliable. We're using global replicated data to make sure that we're resilient in case of data center outages and that kind of thing. And it expands as you need to expand it. It is super performant. It's far more performant than we were actually expecting. When we ran our performance tests, everybody was like, is this the point where table storage falls down? And no, it absolutely flew. We were retrieving data with, in some cases, nanosecond calls inside of Azure between Azure environments. So that was awesome. We've talked about moving to Cosmos DB, but to be honest, we don't need it yet, so we're not doing it yet. That one's on the back burner. We want to do it, but there's other stuff that's more important. We do have a couple of Azure functions that we've already implemented. We did that because we had a couple of really simple APIs. And it's like, you know what? Let's take a risk. We can do this one with an Azure function. We can, again, same as we're going to be doing with the queues, where we're going to learn from the small things and increase it. We did the same with the functions. A really simple one that we can just call. We use it to get configuration data. We're using it to get SVGs for graphs, because the graphs that we have on our screen, we also want in our documents that we produce inside the application. So we have a little Node.js Azure function that runs part of our Angular application that just generates SVGs, so that we can just get those SVGs back, and users are really impressed when they see a graph on the page, which is exactly the same as it is on the screen. And we tried to build this up. It's given us an amount of interesting insights. On the one hand, they work quite well. But on the other hand, there's an amount of quirks that we weren't expecting. We separate our data using VNets. And if you're using VNets, Azure functions are a nightmare. The standard consumption plan, which is the one that we really wanted to use, you can't use inside of a VNet. It has an open public interface, so you can't put it behind an application gateway. So that one, we had to see what the other options were there. We had the choice between a premium plan, which was just ridiculously expensive for our use case, or we could go down the route of hosting our Azure function on the same app service plan that you would host a web app on. You have the advantage of being able to run multiple functions on the app plan because they don't run permanently. So you still get that better use of the resources that you have. But it's also, it's not what we were expecting. So we know that we've got more work to do there to figure out how we should use this properly. Apparently, we've just got an Azure recommendation. You're using VNets, use private endpoints instead. So that's going to be the next thing that we investigate, to try and see whether or not we can get back to that consumption plan, which should scale in the way that we want, and also not be the expensive price of a production-ready app service plan. So we have those ones that we're looking at. We also had a really interesting one, and we are still figuring out why this happens. Our whole infrastructure is inside of its own repo as ARM templates. And when we deploy an Azure function, or when we deploy our environment, if we make a change, running that ARM template resets the Azure function for some reason. We can't see why. Which means that our idea of continuous delivery gets a little bit broken when it comes to infrastructure changes. We have to do that outside of working hours, which we don't want to do eventually. Because once we deploy the infrastructure, we need to instantly redeploy the pipeline for that function. Because otherwise that function's offline and things start to complain. That's kind of where we are right now. We've dipped our toes into the water. We're starting to work with it, and we're trying to figure out the plans for the future.
Yeah, that was my next question. So what are your plans for the future?
I said the plans for the future are we have one bit of one calculation that we do, which is really it's complex and it takes time. And I don't think we're going to make it that much faster in the short term, because that's one of the legacy lift and shift parts. But what we do want to do is not have that affect users. And because we know it takes time, we also don't want it to be calculating every time the user needs the data. So we want to introduce a Redis cache, and we want to give it a kick. Every time somebody changes something in a different service, we want to asynchronously let the calculation know that it needs to refresh the cache, so that when the user tries to get the calculation, they just get the Redis cache back, and they don't have to wait the 5-6 seconds for the calculation. And we're not paying for that calculation to happen multiple times if somebody keeps on reopening that particular dossier. So that's one place that we're looking at. The other one is trying to get education for the developers on how to use functions. I said for the app service plans, we've gone for the onion architecture. So we have our core models, we have our application layer with our business logic, and then we plug different projects into that to make our APIs persistence layer. It works fantastically for a web API. Somebody tried to do that with an Azure function, and it's a bit of a nightmare. So that one, we need to go back and make sure that we get the education that we need, so that, I think, like you say, like the way that students start building projects, we need to get people used to building things that way, so that we can also use that capability.
Definitely. Well, thank you so much. It's always a pleasure talking to you and learning about your process. You're so knowledgeable and I really appreciate you coming over here and sharing your experience. We've learned a lot about how significantly your product has changed over the years, and I love knowing that even if there's never going to be a perfect solution, there's always ways to keep improving, and that's what you're doing. And yeah, did you have any final thoughts or things you wanted to talk about?
No, I think that pretty much covers everything that we've been going through with this solution. I think it's just the main thing that I would say to anybody that is in a similar position to what we were in is the new serverless infrastructure is shiny. It is awesome. You can do amazing things with it, but make sure that it is the solution that you need at that time before you start. Right? It's if you've got a tight deadline, and if you don't have the experience in that space, figure out what you need to use for that time, and make sure that you give yourself an easy upgrade path for later, so that you can make sure you're only fighting one problem at one time, and don't give yourself an overload.
I love that. I think that's great advice in life too. Fight one demon at a time. Don't try to take everything on at once.
Absolutely.
Awesome. Well, thank you so much for joining us today.
Yeah, thanks for having me. Have a good day.